Okay, good day, my students. I believe you are doing great. We want to continue from where we stopped last time we had our class on the three methods of heat transfer. Last week we discussed the three methods of heat transfer and we talked about conduction, convection, and radiation. And we did explain that conduction is a method of heat transfer whereby there must be a material medium in form of a rigid body, a solid body that helps in moving heat from one point to another. And we also went further to explain convection. And we said it is the method of heat transfer whereby there is no solid body contact, but rather there is a fluid in form of either liquid or gas that helps in conducting heat. We now finally explain also, talking about radiation as a method of heat transfer whereby heat can even be transferred in form of electromagnetic waves. That is to say, it can travel through a vacuum without the requirement of a material medium. Now today we want to talk about the applications of method of heat transfer we had already studied. Now, as a way of introduction, let's talk about mechanism of heat flow. That is to say, how does heat flow? We are seeing two boxes. One is coated red and the other one coated blue. The red box is at a higher temperature, while the blue box is at a lower temperature. And you should understand that the heat flows from a region of higher temperature to a region of lower temperature until the two bodies now have equal temperature, which we call equal thermal level. That is to say, the two bodies are now at equal temperature, and at that point in time there is no net heat flow. Now let's continue. Okay, explanation of heat loss. We want to use this picture to explain how heat can be lost. We have seen the three methods of heat loss displayed on the screen. What is happening here? Let's explain. We have a hot object like tea or water inside a cup. Now, since the surface is not covered, the hot liquid is exposed to air medium, and thereby the liquid very close to the object, as you can see, will be heated up. When it is heated up, the density reduces since the volume increases and it becomes lighter, it moves up, while a cold air comes down and takes its place, meaning to say this hot object inside this cup is losing heat to the surrounding through a process known as convection, since air is involved. Now this size, you can see that there is a kind of electromagnetic waves which constitute heat lost through a process known as radiation. That is to say, when an object is heated up, it begins to emit light in form of infrared ray, which is an electromagnetic wave that does not require a material medium for its propagation. So such heat loss is known as radiation. Not only that, the teacup is in surface or in contact with a surface. First of all, the cup is in contact with the tea, so heat is lost through a process called conduction, because if you lift up this cup and touch this surface, the surface will be hot due to conduction, since there is a solid material medium involved. Next one. Prevention of heat loss. Having seen these three processes discussed earlier with the cup of tea, if we want to maintain the temperature of the tea inside a cup so that at any point in time we can use it without losing heat to the environment, we've got to use what we call a vacuum flask or a thermos or a dual flask, as the case may be. This is the diagram. We have a plastic stopper to prevent heat loss due to a process called convection. We have a double wall metal or plastic container, which I will explain shortly what it does. We have a hot or a cold liquid that you want to prevent or protect its heat. Now, let me explain something here. This thermos or vacuum flask is very, very good in the sense that if you pour a hot liquid and seal it up, that hot liquid remains hot for a longer period of time, depending on the strength of the thermos. In like manner, if you also pour a cold fluid or liquid, the coldness is maintained for a period of time until you evacuate the contents. Now let us now see at a close range how this body part helps in preventing heat loss due to conduction, heat loss due to convection, and heat loss due to radiation. Now, working principle of vacuum flask. You can call it Thermos. Let's go. Let me label it. The parts are plastic cup. Normally comes in white and other colors depending on how the flask is actually designed. We have a plastic cup which is an insulator, and we also have the next one is metal casing. That metal casing is to give it a packaging, the outer packaging. We have a vacuum. The vacuum here means that there is no air in this gap. The air has been evacuated, so no more material medium of any kind. This is a cork too also, which is also an insulator, just like this plastic cork, which seals the liquid content inside the flask. Now we have the vacuum seal, and not only that, we have another cork support underneath. Since it is resting on the cork support, heat will be prevented from being lost. Shining surfaces. You can see these two surfaces. We call them double wall. They have been, it's either they are polished or it is made of glassware. That is for some of those flasks that are breakable. They can also come in form of stainless steel for more durability. But then let us now take them one by one and explain how heat can be prevented from being lost to the surrounding. We do say that heat flows from the region of higher temperature to the region of lower temperature. The hot object is at a higher temperature, and the surrounding, which in most cases is at a temperature of 20 to 25 degrees Celsius, which we regard as room temperature. That means this hot object will be losing heat to the environment, and it will get cold in no time at all if these measures are not put in place. What are the measures? Number one, we have the plastic cork. The plastic cork prevents this hot object from having contact with the air in the surrounding, and thereby heat is prevented through a process called convection. Remember, air is involved, which helps in warming up, which when it is warmed up, it takes away part of the heat content of the fluid, and therefore, since the air is not in contact, that means heat is not lost through a process known as convection. Number two, the vacuum. Now we said conduction and convection require material media. The medium for conduction will be a solid substance that requires molecular exchange of heat, while convection requires fluid, which could be air or water or any other liquid. But in this case, since there is no solid, so heat has been prevented by conduction. Since there is no liquid in the gap as well, heat has been prevented by what? Convection. So we can say the vacuum helps in heat prevention through a process called conduction and convection. We see this cork. This cork and this cork are doing the same work, preventing heat loss. Okay, this one is preventing heat loss by convection, but this one is preventing heat loss by conduction. Since this object is not a conductor of heat, it's an insulator, so heat cannot be transferred through this process as such. Now the next one is the shining surfaces. You must understand that heat acts like light. There are some form of light in form of heat that cannot be seen with human eye. We call them infrared ray. So when an object is very, very hot, it can emit and give out infrared ray, and that object will now get cold after such light has been given off. But if you want that object to be protected from the heat being lost, what then do you do? So you should have a means of trying to bounce back the emission coming through the process of what? Infrared radiation. And thereby these surfaces have been what? Polished, like how a mirror helps in reflecting light because it has been polished. Therefore, any heat trying to get out of this vacuum flask, the silvered or the shining surface, it helps in bouncing it back into the fluid body, and therefore we can say the shining surfaces helps in preventing heat loss by radiation. The summary is here because these are targets in WAEC. So every student should be able to draw and label this diagram of Thermos of vacuum flask, and not only that, they should be able to also explain the working principle. Let me now show you how it looks like, so that when next you see it either at home or in other places, you should be able to say this is vacuum flask or this is Thermos, and you can now begin to explain how it works. This is it. Some students have this for their personal use. Some nursing mothers, travelers, they do have this. All the other content we explained, they are hidden inside it. This is just a metal casing, an outer covering. But inside we have the shining surfaces, we have the stopper, we have the vacuum, we have the vacuum seal, and we have the cork and all that. This is the metal covering. We've come to the end of this video. Watch out for my next class, and in case you have any question, feel free to send me an email with this email address, or you could use the first slide to contact me via phone call or any other platform like WhatsApp or Google Classroom. I will be there for you. For now, I am saying goodbye. I still remain myself, Mr. Wisdom Yusuf, physics and further mathematics teacher. Thank you. Bye-bye.